So here I have calculated shear force values. So based on this, now we can easily draw the shear force diagram. For that, I have to draw the diagram of beam once again. Here we have to extend all the points, starting with point A. For drawing SF, we should draw a straight line. SF at point A, the value is minus 200 Newton. So it will be negative. SF at point B, we have two values. One is minus 380, other is plus 620. Next, SF at C, we have two values. One is minus 640 and other is plus 360. Now, as we can see, there is UDL throughout. So if we have UDL, then shear force is an inclined line. So between 200 and 380, there will be an inclined line. Next, the shear force value increases at point B from 380 to 620. And then again between B to C there is UDL. So here I would be having an inclined line. Next, shear force at C, I have two values. It increases from 640 to 360. And finally at point D, the shear force is 0. So this is the shear force diagram which we have. Now after completing step number 2, let us go on to step number 3. Step number 3 is bending moment calculations. First, as we see here, the given beam is overhanging. So at the overhanging end A and D, bending moment will be 0. So first I'll write down moment at A is equal to moment at D, and that is 0 since overhanging beam. Next, bending moment at point B is equal to, first of all draw the convention. Clockwise moment to left and anti-clockwise moment to the right are positive. Anti-clockwise moment to left and clockwise moment to right are negative. So here if I am calculating moment at B, here I have 200 into 1. So my section is at B, and to the left of B I have anti-clockwise moment. So it has to be negative. So minus 200 into 1. Then I have 180 into 1, and that would be acting at half and producing again anti-clockwise moment. So it is minus 180 into 0.5. So moment at B, it comes out to be minus 290 kilonewton meter. Then moment at C is equal to, here I will be having, if I take the section at C, this would be 180 Newton per meter acting at 2 meter distance. So if I multiply 180 into 2, I would be getting the value of force, that is 360 Newton acting at half. So here I have minus 360 into 1, that is minus 360 kilonewton meter. Now, after this, I can draw the bending moment diagram. For this, I will draw an incline, you can say that a line equal to the length of the beam. Bending moment at A and D, they are 0. At B, the value is negative minus 290. At C, the value is 360 kilonewton meter with a negative sign. Now, see here we have a point in shear force diagram where it is changing its sign from positive to negative. At this point, bending moment will be maximum. I'll write it as M max, maximum bending moment. Since there is UDL throughout the beam, bending moment will be a parabola. I will mention this as parabola throughout.